Hi everyone, I'm here to do LeetCode problem number 2873, maximum value of an order triplet 1. Let's see what we have. You are given a zero-indexed integer array nums. Return the maximum value over all triplets. Return the maximum value over all triplets of indices I, j, k such that I is less than j, less than k. If all such triplets have a negative value, return 0. The value of a triplet of indices I, j, k is equal to, included in brackets, nums I minus nums j times nums k. And so it gives you, let's take a look at this example. You're given 12, 6, 1, 2, and 7. You have the triplet 0, 2, 4, and this is a value of 77, and it says that it can be shown that there are no order triplets of indices with a value greater than 77. Same with this one. The answer, the triplet that we found is 1, 2, 4, and the value is 133. Let's take a look at this one. The only order triplet of indices is 0, 1, and 2, which has a negative value of -3, hence the answer will be 0. Okay, so let's take a look at this problem right now. Let's take a look at the constraints and edge cases. That's always the number one thing you should take a look at when you solve a LeetCode problem is the constraints. 3 is less than or equal to nums.length, which is less than or equal to 100. Okay, that seems pretty reasonable. The length of the input array can be as low as 3 and can be as small as 3, but also as big as 100. The values themselves can range from anywhere from as small as 1 to as big as 10 to the 6. Okay. And the topic right here, I think this is an array problem, but let's take a look. Yeah. This is an array problem. The reason why you should check the constraints in the topic always is so that you're along the right path. This gives you checking both these things gives you a faster understanding of the problem, and if you are on the wrong path in the beginning, then it's very hard to course correct. So let's design the algorithm, and frankly speaking, I'm not gonna design the algorithm for you. You have to draw this out by hand, but essentially this is how you do it, right? It's a triple for loop problem. This is a triple for loop problem. You have to do triple for loops such that you're finding I, j, and k that satisfies these conditions. And if you draw it out on paper, you would find that the first for loop goes from 0 to length n. The second for loop goes from I plus 1 to len n minus 1. The third for loop goes from I plus 2 to length of n minus 2. And I'm going to mention right here in the comments that you should set up skeleton first, right? You should set up the skeleton first, and then you do a triple for loop. You calculate the result and return it. So this is probably not going to make sense, and it won't make sense until you draw it out on papers, and I don't have the tools to draw it out for you, so I'm just going to implement it. Res equals 0 for I in range let me see, how about this? N equals length of nums, right? For I in range from 0 to n, for j in range I plus 1 to n minus 1, for k in, spelled wrong, range j plus 1 to n minus 2. We're going to literally copy this right here. I'm going to return result. We're going to do, okay, this is going to be res equals max res, and then so basically we're doing triple for loops. We're calculating the results and seeing if we have to update the result, see if we found a max value that's greater than the previous result value, and we return the result. Okay, so then we press run. Okay, so there's something wrong here. For I in range, it's lens minus 1. There we go. Yeah. Okay. Give me 1 sec. I apologize. I flipped it. This left, the right hand boundary is completely wrong. It's n minus 2, n minus 1, and just n. And then you run. Okay, let me see what's going on. Okay, so after I fixed the upper boundaries of the for loops, I don't need a minus 1, off by 1 error. Okay, and so there we go. Okay, and this is of course a time complexity of O of n to the third, 3 for loops, and the space complexity is O of 1. And I'm gonna fix this. So length of n, it goes from 0 to n minus 2 minus 1, and then n. Okay, so that's the answer. And so I'll see you at the next one.